Hello everyone, welcome to the sixth part in this series on how to create your very own multicolored research-based code-playing program. So in this video, we would start working on some helper functions that would help us to implement some heuristics for the future playouts that we will be having. So mostly these are the functions for essentially the one is to check for move legality, not the 100% legality check, but the one that we would be using within the generated playout move function. Another one is to find the smallest group on board. This will be used further on to figure out whether we want to attack opponent's group if he has the smallest group, or if we want to extend our own group, defend, try to save our own group. And finally, creating a function to make an engine playing a random move within a given range of squares, and that will also be used during playouts, sort of a tanuki kind of moves. We would have very simple playouts because playouts are meant to be played in a fast way. And probably later we'll also add some ladder detection into the logic of generating a playout move. But for now, just to kickstart with things, I think that just the bare generate moves with a semi-random kind of extension when it comes to saving the group, with a semi-random attacking the group or having the least liberties, although it might not always be, say, capturing a group into a ladder, which is not good. But anyway, generally, it plays quite interestingly. We'll have a look at that already in the next video. But again, to be able happily watching how the playout is happening, we first need to implement this helper function. So without further ado, let's get started. So I keep going from the part 5, the last one. So here, I've made some slight changes in the code layout. So I added some headers here, and now the code is organized in a little bit different way as opposed to how it was earlier. Heuristics is now empty, and the GTP is down below. So yeah, I just made it a little bit different structure, but essentially all the code that we've written already within the previous videos is available over in here. So feel free to download this template to keep going from here. Okay, so the first function to create would be checking if the move is suicide or not. So I can say function, and this would be again traditionally the part of the board structure, and I call it not suicide. Okay, and it takes square as an integer, and it returns a Boolean value. So true if it's not suicide, and false if it is indeed a suicide move. So we kickstart with defining liberties. Okay, so liberties is going to be equal to 0 at start. Okay, and then I want to define the array of neighbors. Essentially, this is a slice in terms of Go syntax, so slice of integers. And here we can populate it. So the neighbor 1 is to the east, -1, this is west. Then board size, whatever the board size is south, and minus board size would be the north direction. Okay, so next thing, we simply want to loop over all the neighbors. So I say for I equals to 0, I is less than 4, because we have up to 4 elements, and I++. We could have do like length of neighbors, but this would result in a slightly slower execution. So essentially we want to be our code, want our code to be as fast as possible. So I just use the constant of 4, since the amount of neighbors will always be 4. Right, now a condition. So I can say if board position indexed by a given square plus neighbors indexed by I. So essentially here we check square plus 1, square minus 1, square plus board size, square minus board size. So if it's equal to empty, it means that in a square we're about to place our stone, after we place a stone there still would be some liberties, at least one liberty. If there would be at least one liberty, then we do liberties plus plus. Okay, so this is how we know if the move is suicide or not. Say we have a group of stones and there is only one liberty left, and if we fill that liberty, that would be our self-capture. So in this case, if we check that exact place, that exact square, using this not suicide function, it would give us that it is indeed a suicide. Okay, so we cannot place a stone there. Now, let's just keep going from this line. So after the for loop has ended, we ask if board position indexed by the square. So it should be an empty square. So not just having some liberties, but where we're supposed to be play our stone, it should be empty. This is quite important. And because when we would be extending, or not extending, when we would be trying to save our group, it might happen that we do a suicide move, so we don't want that to happen. So if it's empty, and also obviously if it has liberty, so liberty is greater than 0, and also if square is not equal to board.co, so we're not stepping into the code. In this case, we want to return true, which means the move is legal in terms of it's not a suicide move. Would be having an extra check for legal moves using the function to play the stone on board. It might feel a little bit complicated, but in some cases the move generator would be generating illegal moves, but that's quite hard to avoid. So since those cases are not going to be very oftenly encountered, so well, anyway, it's not the case at the moment. So otherwise, we just want to return false, which means that move is indeed a suicide. Okay, so if one of these conditions does not work, then this move is suicide, then we are not going to consider that move. Okay, next function I want to define is called target. So target is going to be looking for the smallest group on board to do something with, either to attack or to defend. So I say function, and again this is the part of the board structure, and I call it target, and it takes color as the only argument, and it returns the slice of integers. So here we also define liberties, but this time liberties is going to be the slice of integers. Okay, and we define the smallest variable equals to 100. That's just a relatively big number. So for square is equal to 0, square is less than board size multiplied by board size. So we look over all the squares on board, square plus plus. We define a stone, which is going to be equal to board position indexed by the square. Okay. Now, if stone is equal to off board, then we want to skip it, so continue. Okay. And now finally, if it happens that stone matches the color, in this case, so it's greater than 0, yeah. In this case, we want to count, to call ball count function to populate the group array and the liberties array. In particular, we'll be interested in liberties array, so we're looking for a group containing the least number of liberties, no matter how big the group is. We could also add this logic to also take into account the size of the group. So say we have two groups with the same number of liberties, then the one that is bigger is more likely to be attacked or defended. But yeah, for now we are not doing that. So maybe that would be a future improvement, maybe not. Now it's very hard to say. So we do board count and give it a square in color, and I have to do board.restore. Okay, and in between I say if the length of board liberties is less than smallest. Okay, so number of liberties is less than 100. Okay, in this case we update the smallest equals to the length of board liberties. Okay, and also we initialize our liberties equal to board liberties. So it's very similar to what happens in Nigamax or Minimax search when it comes looking for a best score. Okay, finally we do, yeah, I want to make this a single line, so this kind of syntax. And after the for loop, we just return liberties. And that's kind of it. Okay, let's make sure it compiles. So go build and go. Okay, smallest is undefined. And yeah, just a typo. Okay, so we are in a loop, right? Yeah, great. So it seems like it's working properly. Anyway, we'll be testing this in the next video because if I do everything in one single video, it just takes ages to complete. Let's now implement the last but not least function called random. So board pointer to the board struct and call it random. It would take an offset as an integer, so whether we're supposed to be covering the second line or the first line, so the lowest line that we're supposed to be covering when it comes to generating random moves. So when it comes to the end game, we also want to generate moves on the second line and on the first line. In the opening, we don't want that, so that's how we're supposed to be using this function. So if we ran out of moves on the third line and in the center, then we start generating moves on the second line. If we run out of those, we start generating moves on the first line. The general idea behind this, when it comes to playouts, the playouts are not meant to be a strong engine by on its own. They're meant to be given a multicolored research an idea of how likely, from the probability perspective, a kind of variation is about to be formed. And we need it to be as fast as possible on the one hand. On the other hand, we want it to be played to the very end of the game. We need to avoid having dead groups and territory that does not belong to anyone. And still, there might be a few points of territory that do not belong to anyone, but that's not a big deal. So we'll generally be capable of saying who won the game, and this is crucial for the multicolored research-based program to know who won the game, because unlikely Nigamax with static evaluation, which just gives the score, with the multicolored research, this is quite important to know, like the terminals, that when the terminal state of the game has occurred, and we need to evaluate that state as win or loss. So that's quite important. Okay, This random move is going to be returning an integer, which would be the move itself. So let's have a look. And I just create moves, or the variable moves, and this would be the slice of integers. We will be picking up the random from those later. Okay. So now we need to loop over both rows and both columns to make sure we can apply the offset. So for row equals to 0, row is less than board size, and row plus plus, and same for columns. So okay, and here, if row is greater than offset, and row is less than board size minus offset minus 1. And also if column is greater than offset and column is less than board size minus offset minus 1. In this case, we just want to populate our moves, so moves would be equal 1 to append to moves, and the square, to calculate the square, we simply do row multiplied by the board size and plus the column. So this is the formula to convert row and column into the square. Yeah, and not minus 1, but plus 1, like this. Right. Then finally, want to return the moves, but not all of the moves, obviously, but we want to return the random move from our list of moves that are kind of available there. So I just do return moves and rand int number and the length of moves, and I probably need to import random to make it kind of working. Okay, maybe not. Interestingly, quit. Yeah, maybe this is because, okay. Yeah, math rand has been imported. Yeah, so this is another update since the very last episode. So it now has the math rand being imported as well as time, and also in the main function, this function call to set a random seed. So this is another stuff that has been added since the last video, but I didn't mention it. Sorry for that. So because of this, we have everything working. Okay, let's get back to the random function. Okay. Yeah, quite simple and straightforward. And one last thing before I forgot. So there were another couple of tiny little bugs, but they need to be fixed. So column is greater than 8 in the square routine, square, board square. Yeah, so here it was like if column is greater than 8, but it should be if column is greater equals than 8. So otherwise it might not be working properly on smaller board sizes. So this is important. And another thing is within the pass, within the GTP, yeah, this one, this line was missing. So if our program passes, it needs to tell about this to the GUI, all right? So otherwise GUI would not know that the pass has occurred. So this is another important thing here. Yeah, now this being said, I can get rid of my to-dos here, and final compiler run, quit. And yeah, next video will implement a routine to generate a move for a playout, and we'll also put in some code to essentially print that would make it possible to test playouts within the GUI so that we can see how engine is playing against itself. So what in particular is going to be happening during the playout. Since that code would be a kind of a throwaway code, I would just copy paste it and quickly talk through that code, because we'll throw it away quite soon, and that will only be serving for the purpose of demonstration. But since it's quite a huge amount of code, I just don't really want to see me typing that forever. So I will type in the gen move function, generate move function for a player, but the code for the GTP driver part, that would be just a copy paste. Yeah, okay, so this is it from my side. Thanks for watching, and the next video is hopefully going to be more exciting than this one. Yeah, see you then, and cheers.